Good evening, all of you. Am I audible to everyone? Please respond. Can you all hear me? If yes, you all can respond via chat. If I'm audible to all of you, please respond via chat. Everyone. All right. So this is the second session of time, speed, and distance. Now, in the first session, we have started with the very basics of time, speed, and distance, and we have discussed one particular technique here, that whenever there is an interchanging of speed or interchanging of distance or time, then how can we solve such type of the questions quickly here, okay, without framing the equations here. So today also I'll be discussing few more techniques here, okay, how to solve a questions which we can done in quickly. All right. So we all know that there is only one formula in the entire time, speed, distance, that is equal to distance is equal to speed into time. All right. So let's start here and we'll see how to apply this formula in a different variety of the questions, and if we can observe some pattern and we can apply in some similar type of the questions here. So let's start. Now, a very simple example here. I'm starting with a very simple example, and I'm sure that you all can spend uh, some time and you can get the answers quickly also. But that is not the reason here for discussing this question. Getting answer is not important as of now. Okay. So just give me a minute. All right. So let's see how we can do this question here. And I'll discuss by 2-3 different approaches, and all the approaches are important. So please pay attention here. It says if a man walks at a rate of 7 kilometer per hour. So it says if the man walks at a rate of 7 kilometer per hour, he misses a train by 9 minutes. So let me write down two parameters are there here. What are the two parameters? The first parameter is nothing but that is speed, and the second is time. If the speed is 7, that is actual speed is 7, he misses the train by 9 minutes. So can he say t minus 9 by 60? If the actual time taken is t, so now he will take how much time? T minus 9 by 60. However, if he walks at the rate of 8 kilometer per hour, he reaches the station 6 minutes before the departure. So he reaches early, 6 minutes before. So I can say t plus 6 by 60. All right. Or if he travels with the normal speed s, let's say the time taken is equal to t. And we need to find out what is the distance to the station, original speed of a man, and find the normal time taken by man if we travel with his original speed. Okay. Hi, Vonik. All right. So let's start here. Now, first I'll discuss with the very general approach, and then I will discuss a lot of shortcuts. We'll learn a lot of things here which can be applied in a similar type of the questions here. Okay. So first of all, method one. Let's see what is the method one. A traditional approach. I can say that the distance is always equal to speed into time. So I can say distance is equal to nothing but speed into time. We can write down that distance is equal to speed into time. All right. Now, after that, when the speed is equal to 7, time taken is nothing but I can say t minus 9 by 60. All right. And when the speed is equal to 8, that is 8 into t plus 6 by 60. And that is over. Okay. Now, it's a very simple equation. You can see here, there is one equation, one variable. But the problem arises in the probably in the next question where there will be two variables here. So then how to solve it? So I can solve these two equations and we can find out the answer here. I can say this is nothing, but that will be equal to this. We can calculate here, solve these two equations, we can find out the t. So like I can say that is 7 into 60t minus 9 is equal to 8 into 60t plus 6. So 60 into 7, that is 60t into 7. I can say 7 into 60t minus 63 is equal to 8 into 60t, okay, plus 48 here. All right, plus 48. And then we can solve this and we can find out what is the time taken here, isn't it? So T, he reaches 6 minutes before, misses a train by 9 minutes. Okay. One mistake which I've committed. This is T plus 9 and T minus 6 here. 9 minutes late. So it means he's taking 9 minutes extra. So it will be T plus 9 and 6 minutes early. So you should write down T minus 6. Okay. So I'll just change my equation once again before I proceed further. So T plus 9 by 60, T minus 6 by 60. So this is my equation here. Okay. All right. Let's try to solve these equations and we can find out the time also. So 7 into 60t, okay, plus 63, 8 into 60t minus 48 here. So I'll say it will be comes out to be equal to 8 into 60t, or you can take 48 on the right hand side. So this will be equal to 63 plus 48, and that is equal to 8 minus 7 into 60t here. So the value of t, 63 plus 48, it is equal to 111. So 111 by 60. So now we know the time. Okay, this is the time. If we know the time, substitute this value in any of the equations and we can find out the distance. All right. So let me substitute this value of t, which we have find out in the first equation. So what is the distance? Distance is equal to nothing but 7 into, I can say 111 by 60 plus 9 by 60. So that is 7 into 120 by 60, which will be equal to 14 kilometer here. Okay, so the distance is equal to 40 kilometer. We have find the time. Substitute this distance or maybe time in any equations. You can also find out the speed also. All right, like I can substitute this in this equations and we can find out the speed also. We already know the distance. All right, we already know the time. We can find out the speed. Speed is what? Distance upon time. So distance is equal to 14 and time is 111 by 60 that we have calculated. So that is 14 into 60 by 111. All right. And this will be any case 3 into 37 and 3 into 20. So that is 280 by 37. Okay. So that is going to be speed, which is in terms of kilometer per hour. So I hope that it is now clear to all of you. So it's a very simple example. Again, it can be solved quickly. Now let's discuss other approaches also, which is very important, especially when the next 4 questions which I'm going to discuss, that is based on that particular concept here. We can't solve it directly by framing the equation like this here. Now, so let me talk about the method 2 here. Okay, method 2. So I'm going to erase everything and we'll try it by method 2. Okay. So let's talk about the method 2. Now, what is method 2 here? Okay, the pattern, try to understand speed and time. There is a normal speed, normal time. In one case, if my speed is 7, I misses a train by 9 minutes. So this is t plus 9 by 60 and then 8, and then I can say that is t minus 6 by 60. Now what is happening if I say this is a line here? Okay. So in one case, I am misses a train by 9 minutes. So I'm late by 9 minutes. So 9 minutes. So I'm taking plus 9 extra. In another cases, I'm reaching 6 minutes early. So I'm reaching 6 minutes early. So minus 6 here, I can say. So what is the total gap between these two time slots? That is nothing but that is 15 plus 9 and minus 6. You can see the gap will become, total gap will be 15. Like if I'm here, so 9 minutes extra from my hand. So I'll take 9 minutes on the right hand side and 6 minutes early, 6 minutes early. So this total gap is of 15 minutes. So basically the time gap between these two is nothing but that is 15. Even if you take a difference between these two, but do not try to do it the calculation. If I take a difference between these two, it will comes out to be 15 minutes. Okay. Now, so I can say in the first scenario, what is going to be happen here? Time taken is equal to distance upon speed. So that is d by 7. In the second case, time is equal to distance upon speed. Okay, and what is my speed here? That is 8. So d by 7 minus d by 8, and that is given to us as 15 minutes. So that is equal to 15 by 60. And from here, I can straight away get the answers. 15 by 60 is equal to 1 by 4. So if 15 by 60 is equal to 1 by 4, I'll get what? D by 7 minus D by 8. 8D minus 7D upon 7 into 8, it is equal to 1 by 4. And then D will be 14. And then once we get a distance 14, so we can find out speed as well as time, original speed and original time also. So this is another way also, and I think this is much more quicker. Okay. So this is a method 2 here. Now let's discuss another thing which is very, very important for all of you. Okay. What happened in this case here? First of all, I'll tell you T1, time 1 in the first case. Now remember, my distance is constant here. Okay, distance is constant. Whether I'm traveling with a speed of 7 or with a speed of 8, the distance is constant. So I'll say time 1, it is equal to nothing but D upon S1. Okay, distance upon speed 1. And in the second case, I can say that time 2, it is equal to nothing but that is equal to distance upon speed 2. Now distance is fixed, and D by S1 minus D by S2, it is nothing but that is the equal to how much? D by S2. So let me write down D by S2. Okay. So D by S2, that will be equal to T1 minus T2. So I can say this equation is what? D into S2 minus S1 upon S1 minus S2, and that is equal to T1 minus T2. So distance is basically nothing. This is S1 into S2. Distance is equal to nothing but S1 into S2 into T1 minus T2 upon S2 minus S1. And what is the difference between these two? I can say change in time. Change in time here. So I can say distance is nothing but basically the product of the two speed into change in time delta t upon change in speed, that is delta s. And I can write down this way. A very, very important result which can be, with the help of which you can solve a difficult question within seconds. And believe me when I'm saying within seconds, so yes, you can solve it within seconds here. Okay. The question which usually takes 3-4 minutes, it can be done within seconds or within a minute here. Now, same thing. This is the thing which we have used in the question number 1. Similar scenario if I say S1. So S1 is equal to nothing but distance upon time 1. S2, it is equal to D by T2 if the distance is constant. Now, so what will happen in that case here? If I take a difference between these two, what is going to happen here? I can say S1 minus S2, it is equal to what? D upon T1 minus D upon T2. So S1 minus S2. Okay, D is common and I'll say that is T2 minus T1 upon T1 into T2. So what is D? D is equal to T1 into T2 into how much? S1 minus S2 upon T2 minus T1. And what is S1 minus S2? The difference of 2 is T. I can say distance is equal to T1 into T2 into S1 minus S2 is equal to how much? That is delta S upon delta T. Okay, that is the case here. So now you can see here, if the distance is constant here, it is equal to the product of two speed into change in time upon change in speed, or the product of the two time into change in speed upon change in time here. I can easily remember, if it is a product of speed, then in the denominator there will be a change in speed. If it is a product of time, in the denominator it is a change in time here. So if I apply this formula in the previous question, like question number 1, which you have done, what was the question here? Okay, the question was given to us was speed and time. So when the speed was 7, speed was 7, I reached 9 minutes late. So plus 9 extra. I'm taking plus 9 extra. And when I'm traveling with a speed of 8, I'm reaching 6 minutes early, minus 6 here. Okay, minus 6 here. So this is the two different speed and the two different time here. Okay. So what is the time gap between these two? That is plus 9. I can say T plus 9, T minus 6. So that will be, the gap will be 15, or you can think directly plus 9 minus 6. So the gap is 15. So straight away I can say the distance is equal to 7 into 8 into 15 by 60 upon change in speed. What is the change in speed? These two speed, that is equal to 1. That's it. And the distance is nothing but that is 14 kilometer. So what I have done, I have simply derived this formula here for what we have done in the method 2, nothing more than that. Now there is another approach also, that is by using the method of ratio and proportion. But that method I'm going to discuss in the next lecture when I discuss the concept of proportionality, how to use the concept of ratio and proportion in time, speed, distance. Okay, at that point of time, I'm doing a variety of questions with application of that particular concept. So I'll discuss the same question again with that method here. But yes, this is very, very important. So you all can note it down. Take care, you won't find out it anywhere. Okay, that's it. Now, let's see how to apply this in the couple of other type of the questions here. Okay, so the important thing, a moving object covers the distance d. If T1 and T2 be the original and the change time, and S1 and S2 be the original and the change speed, then change in time is T1 minus T2. Change in speed is, you can take S1 minus S2 or S2 minus S1. Okay, and this is the formula which I have derived. So basically this one is important, that my distance is always given by this. Okay, so I hope that it is clear. Can I move to the next part? All those who are attending it live, Rishikesh, Bhaumik, and everyone. And my advice to all of you is that try to attend the sessions live. Okay, every day, like I told you, every day from Monday to Friday, I'll keep taking a session of around 40 to 45 minutes of Quant. And if the responses will be good enough, then I can increase the number of hours also. And I'll discuss the other topics also. So you can share the link of all these YouTube live sessions among your friends. You can join our WhatsApp group, not WhatsApp, but Telegram and the LinkedIn group. Okay, now just here, we need to solve this one. A car travels a distance of 840 kilometer at a uniform speed. If the speed of the car is 10 kilometer per hour, it takes 2 hours less to cover the same distance. Find the original speed of the car here. So here, first of all, observe that distance is nothing but that is constant here. Okay, the distance is constant. So there are two things I'll write down: speed and time. Okay, first case, speed is s, time is t. If the speed of the car is 10 kilometer per hour more, that is s plus 10, it will take 2 hours less, t minus 2. So two scenarios. What is the change in speed? Change in speed is 10 and change in time is 2. Okay, so I can say, simply apply the formula here. Okay, distance, it is equal to 840 is equal to s into s plus 10. Okay, into change in time 2 upon change in speed, that is 10. So I'll get a very simple equation. And what is this value comes out to be? I can say s into s plus 10. It is equal to 840 into 10 by 2. Okay, 840 into 10 by 2. So, or I can say for 420 into 10, that is 4200. And do not try to solve it. Okay, so do not try to solve it. Do not try to make it a quadratic equation. I basically need a product of two numbers is 4200. And if the answer is not in the fractions, so I can say probably I'll look for, try to factorize this. I think it is nothing but 70 in 60 into 70, isn't it? 60 into 70. 60 into 70 is 4200 and this is 60 plus 10, 70. So speed is nothing but that is definitely, it is equal to how much? 60. That is the speed. Okay, so I hope that it is clear. Vatsal, Avinav. Okay. Now, another interesting thing, like I told you, every question I can discuss a lot of different approaches, but your target should be to easier one. I can also say formula distance is equal to speed into time, which is equal to s plus 10 into t minus 2. Solve these equations and you can get the answers. Like if you solve this, remember what will happen. That is also very important fact here. If you try to solve this equation, it seems to be difficult, but the terms will actually get cancelled here. Okay, s into t and then s plus 10 into t minus 2. But I think it will be difficult even in that case. If solve it, you'll get a one equations having two variable, then you further need to substitute it and then solve it. It might be a time consuming. Okay. Or I can say the time gap is 2 hours. So I can say time gap T1 minus T2, it is equal to 2 hours. So distance upon speed. So 840 upon speed minus 840 upon s plus 10, which is equal to 2. But this is the same thing. No? We have derived the formula. Yes, Vomik, I will conduct. Let me first finish the basics, that is Vedic maths and the calculation technique. Like my target for this week is to complete the Vedic maths and the calculation techniques. Then I will be starting with the DILR from the Monday. Okay. So I'm discussing, I'm sure that you all have gone through. Like tomorrow I'll discuss Vedic maths, and then next 3, like Wednesday, Thursday, Friday, do not miss that session. I'll discuss the calculation technique, how to do all the calculations in a faster way. And then we'll start with the Monday DILR. All right, guys. Let's take the question number 3. This is something where, this is one question where people actually struggle a lot. So it says a man covers a certain distance with his own speed. But when he reduces his speed by 10 km per hour, okay, his time duration for the journey increases by 40 hours. So now here the distance is constant here. Okay, that is important. The distance is nothing but it is constant here. Okay. All right. So the distance is constant. If I'm traveling, so I'll write down 2 parameters, that is speed, and the other parameter is nothing but time. A man covers certain distance with his own speed, but when he reduces the speed by 10 km per hour, so he reduces the speed by the 10 km per hour. Okay, so I say, let's say he's traveling with some speed that is s, and then there is a time t. If he reduces the speed that is s minus 10, then what is going to happen in that case? The time taken is increased by 40 hours. So that is t plus 40. Let me highlight this. Reduces his speed by 10, the time increased by 40. While if he increases his speed by 5, the original speed, he takes 10 hours less. Okay. So 10 hours less. So in the second scenario, s plus 5 and 10 hours less, t minus 10. Find the distance covered. Okay. How will you calculate that? I'll say distance is equal to speed into time, which is equal to s plus 5 into t minus 10, which is equal to s minus 10 into t plus 40. And the problem starts from here. How to solve this equation? Okay. Solve these equations. You can find out speed, you can find out time here. And I'll tell you also, if I need to solve these equations, how can I solve it? First, I'll try to solve these equations. Now, this is method 1. Or I'll say, do not write down method. That is solve. How to solve it? I'll discuss it after probably 3-4 minutes. Let's discuss just the approach which I've discussed right now. Okay, so I'll go for method 1. And what I have derived? Distance. So in one case, I'll take the first 2 here. Okay, I'll take the first 2 here. These 2. Okay. So in that case, you can say s into s plus 5, product of speed, that is s into s plus 5, into change in time, which is 10, and upon change in speed, that is equal to 5. All right. And the same way, if I try to make the equation for the second case, let me take a highlighter. This one. If I take these 2, Then I can say in one case speed is s, in another case it is s minus 10, isn't it? S minus 10. And into how much? Change in speed, or sorry, change in time, which is equal to 40 upon change in speed, which is equal to 10. And now you can easily see that s and s will get cancelled here. Yes or no? So what is my equation here? My equation will be equal to nothing but twice of s plus 5, which is equal to 4 times s minus 10. And we'll get a very simple linear equation. It's not even a quadratic here. So I'll getting here s plus 5, which is equal to twice of s minus 10. So s plus 5, which is equal to 2s minus 20, and then s is equal to nothing but that is 25. So we have got that our original speed is nothing but 25 kilometer per hour. And if the speed is equal to 25 kilometer per hour, what is the distance? I can say distance, substitute in any value, we can get the distance. So distance is equal to, I can substitute probably in the first one here. Speed is 25, 25 plus 5, that is 30 into 10 by 5. Or you can put in the second equation. And if I solve this, what is this value comes out to be? 5 5s are 25. So 30 into 5, which is 150, or that is 1500 kilometer. So that is the distance covered by him. And what is the time, actual time I'm talking about? The actual time. So actual distance is 1500, actual speed is 25. So 1500 upon 25 will get the answer, which will be equal to 25 6 or 150, to 60 hours. So just here we have done it here. Okay, and it won't take too much of time if you know, if you have understand this shortcut. I'll say shortcut, or maybe I have derived a formula for tackling such type of the questions. Now let's go for another approach. If we try to solve this equation, then what is going to happen? Any doubts to anyone in this method? Please tell me. Those who are present. I keep seeing some of you are joining, then again logged out. Anyway. So Vatsal, if you are here, Rishikesh, Avinav, if you guys are here, please tell me if there is any doubt. Now, if I go try to solve it by the actual method, by framing the equation. Okay, do not worry. I'll try. Let's see. But yes, if you solve the questions which I'm discussing in the class, that will be more than enough, in fact, believe me. Just attend till next week and probably you feel confident about this. Okay. All right. Let's see. Let's move to another method here. If I try to solve this equation, so I'm going to erase everything. I hope that you all have noted it, all this formula and how I have solved it here. Okay. So same thing here. So let me take some other screen. If let me see. Okay. So I've just taken another screen here. All right. So if I try to solve it here, it's going to be time consuming. Why it's going to be time consuming? Yes. Now just here. I'll write down what was the value, speed and time. Okay, Rishikesh. Just here what I have done here. Let me take one. Now, I hope that you have understood the formula which I have derived here. So I have just directly used this formula, nothing more than that. Okay, this is the formula which I have derived earlier. That distance is equal to, always equal to, product of the two speed into change in time upon change in speed, which is also equal to product of the two time into change in speed upon change in time. All right. Now, here, if you observe here, so what I have done in this question, first scenario, when it is s plus 5 and s, change in speed is 5 unit, and t minus 10 and t, the change in time is equal to 10 units. So I just applied the formula, distance equal to s into s plus 5 into change in time upon change in speed. In the second scenario, it was s and s minus 10. So change in speed is 10. And in this case, t and t plus 40, change in time is 40. So s into s minus 10 into 40 by 10. S and s will get cancelled. We'll get a very simple linear equation. And from there we found the speed, that is 25. And once we find that the speed is 25, substitute it here, we'll get a distance like 25 into 25 plus 5, 30, and into 10 by 5, we got a distance. We know the actual speed, we know the distance also, so we can find out the time also. That is distance by speed. Now I hope that it is clear. Is that clear now, Rishikesh, Vatsal, and everyone? Now, other way, like I told you, that you can also use, you can try to solve the equation, but I'll say the disadvantage of using the equation is it might be very, very time consuming. Let me show it to you, all of you. You should know, such that then only you can apply all this concept while solving the question here. Okay. So what was given here? I'll say speed. The equation which you have framed, that is speed into time, which is equal to s plus 5 into t minus 10, and that is also equal to nothing but that is equal to s plus 5 into t minus 10, s minus 10 into t plus 40. Like I told you, method 1, but then I stopped there. If you try to solve it, it will be very lengthy. But yes, we can, few patterns you can observe. This is s into t. S and t will be get cancelled. This 5, okay, s into t, and then s into 10, that is minus 10s, plus 5t, and minus 50. And s and t and st will get cancelled, and I'll get that is equal to 10s, or maybe I can write down that is 5t minus 10s is equal to 50. Similarly, if I solve these two equations, which two equations? Let me write down here. That is st is also equal to s minus 10 into t plus 40. So this is st, which is equal to st plus 40s minus 10t minus 400. Again, st and st will get cancelled, and my equation will be that is 40s minus 10t, it is equal to 400. Now there are two equations, two variable, and I'm sure that you can solve these two equations, two variable, and you can get the answers, same answers. You can find out the speed and you can find out the t. Now once you understand, remember that the term st is getting cancelled. So I can write down these equations orally also. How? Let's see here. Speed and time. In one case, my speed increased by 5 and the time decreased by nothing but t minus, okay, decreased by 10. Where I have written, by mistake I erased that thing. Okay. All right. No issues. All right, I'll write down here. So I told you that speed and time. So in one case, my speed increased by 5 units. Okay. And then plus 5. So the time I am taking how much less? Minus 10. So how we can write down the equations quickly here? Write down this 5 into t and multiply this. So that is 5t minus 10s, and take the product of 5 into 10, which is 50. So this is one equation. Okay, this is one equation. All right. Yes. Or the second case, I can say that is another thing. In the second scenario, if my speed decreases by 10, minus 10, and then if it was minus 10, I think the time increased by how much? It increased by 40. I think it was by 40 hours less. I don't remember. Let me check here once again. Yes, 40 hours less. Plus 5 minus 10 minus 10 plus 40. Yes. So minus 10 and plus 40. So again cross, and you can write down the equations again here. Okay, na? That is this and this. So minus 10t plus 40s and minus 10 into 40, 400. And then solve this, you'll get the answer. So that way also, that is a pattern which you can observe here. But I think the formula which I discussed, that is very, very important, with the help of which we can get the answers quickly. Is it clear now? Rishikesh, Vishal, everyone? Avino, if you are here. Can I move to the next question and a few more application of this concept? Because again, solving this might be time consuming, and in that case, it is not taking too much of time. We get basically the formula which I've derived, and if you use that, you'll get only one equations having only one variable, and that too linear equation, which can be solved quickly. Okay, so can I move to the next slide? Please tell me. All right. So try this question, all of you. Try this question, all of you. So again, it says a man covers a certain distance on a scooter. Had he moved 5 km/h faster, so speed s, time t, 5 km/h faster, so speed plus 5, you take 10 minutes less, so t minus 10, 10 minutes less. If he had moved 5 km/h slower, remember this is in minutes, 5 km/h slower, so s minus 10, not that is s minus 5. Okay, you'd have taken 15 minutes more, so t plus 15. Okay, so again same thing, I'll say first write down this. So distance is equal to s into s plus 5 is into change in time, which is equal to 10. I'll write down by 60. Why by 60? Because the time is given in terms of minutes, so I converted that in hours. So into 10 by 60 upon, that is change in speed, which is 5. It is equal to, take second scenario, s into s minus 5 into change in time in the second case, that is 15, and change in speed is nothing but again 5. So you can see here s and s will get cancelled, this 5 and 5 will get cancelled, this 60 and 60 will get cancelled here, isn't it? So what I have got, that is s plus 5 into 10, which is equal to s minus 5 into 15, and then 5 2s are 5 3s are 15. So I'll get 2s plus 10, which is equal to 3s minus 15. So the value of s, it is equal to 25. That's it. And once you get a speed, now you can find out the time also. Substitute this value of s in that equation. So distance is what? 25 into 25 plus 5 is 30 into 10 by 60 upon 5. Do not forget to divide by 60. Minute conversion is very, very important. Minute to hours or hours to minute. Okay. So if I solve this, this will be probably 5 times. So I'll say 30 into, okay, and this 30 2s are 60, 2 5s are. So distance is also coming out to be 25, I think. So anyway, is that clear to all of you now? Any doubt? Okay. Now, one very, very important thing, special, that's a special case. If the change in speed is same, I can solve it by another method also, like AM, GM. AM and HM, arithmetic mean, harmonic mean concept, but that I'll keep it for later. If the distance is same, sorry, change in speed is same, not change in speed, but yes, change in speed is same. So you can see that my change in speed, it will actually get cancelled, isn't it? Like I'll say one of the speed is s plus 5 into change in time, that was 10, upon change in speed, delta s, write down. Second scenario, s into s minus 5, change in time 15 upon change in speed s, delta s will get cancelled, this one will get cancelled. So basically s plus 5 upon s minus 5, it is simply equal to 15 is to 10. Observe this, this is 15 into 10. So it's a very special case, same thing here. If the change in speed is same, then straight away I can say the ratio of these two, that is s plus 5 is to s minus 5, always. Let me, these two ratio, it will be nothing but in the ratio this 15 is to 10, change in time upon this one. So of course I'll put here 15 is to 10. Okay. So directly, but a very special case if the change in speed is same. So 15 is to, and in fact, this will be in the ratio 15 is to 10 here. So we can use that fact also, and I can say, okay, in the speed there is a gap of 10. In the speed you can see there is a gap of 10, and here in the ratio there is a gap of 5. We need a gap of 10, so I will multiply by 2. So 15 into 2, 10 into 2. So s minus 5 is equal to 20, s plus 5 is equal to 30. So actual speed is 25. That's it. 25 plus 5, 25. So here I've used the ratio and proportion method approach for solving. But that's a special case. Not only this, but in fact, the time will be also in the ratio 15 is to 10. So this will be 10, this will be 15. ये जो ratios होंगी, ये भी ratio time का भी 10 is to 15. Why 10 is to 15? They will become reverse. Okay. So you can see in the time there is a gap of 25 minus 10 plus 15. There is a total gap of 25. So in the ratio also I should get a gap of, in the ratio there is a gap of 5. So multiply it by 5. So that is 50 and this is 75. So my actual time is 60. 60 minus 10, 50, 60 plus 15, 75. So we know that speed is equal to 25. Time is equal to 60 minutes, which is 1 hour. So distance is also 25 into, that's it, 1, which is 25. But that's a very special case here. I hope that it is clear. Yes or no, please tell me. I'm going to repeat, just pay attention. A very special case if the change in speed is same, like here. So straight away, in one case, speed is s plus 5. In another case, speed is s minus 5. In one case, the time is equal to t minus 10. And in another case, the time is t plus 15. But the ratio of this will be, if the change in speed is same, it will be 15 and 10. So this is in the ratio 15 is to 10. And we can work on the ratios here. All right. And here the ratio will be reversed. That will be 10 by 15. That's it. But a very special case. And you'll get the same answers as we have seen. Either you can use that direct formula, but if it is a special case, then you can do it. And the same thing, very wonderful thing here, like in question number 5. It says a man covers a certain distance on a scooter. Had he moved 3 km per hour faster, so s plus 3, he will take 40 minutes less, so t minus 40. Okay. In the second scenario, if we move with a 2 km per hour slower, s minus 2, he will take 40 minutes more, t plus 40. So here the change in time is same. Okay, now change in time is same. Now even if change in time is same and the speed is this one, so now they will be in the ratio of the speed, that is 3 is to 2. So here these two will be in the ratio 3 is to 2. And what you can think, just think, s plus 3 is greater than s minus 2. So 3 will be corresponding to s plus 3 and 2 corresponds to s minus 2. And these two times will be in the ratio 2 is to 3. T minus 40 is smaller, t plus 40. Okay. And then I can work on the ratios like this. Here in the ratios, in the actual, there is a gap of how much? 5. S plus 3, s minus 2, there is a gap of 5. So in the ratio also there should be a gap of 5. But between 3 and 2, there is a gap of 1. और मुझे 5 का गैप चाहिए. अगर 5 का गैप चाहिए, so multiplied by 5. 3 into 5 and 2 into 5. So s plus 3 is 15. S minus 2 is equal to 10. So s is, in any case, that is 12. Same logic here. T minus 40 corresponds to 2. T plus 40 corresponds to 3. In the ratio, there is a gap of 80. Minus 40 plus 40, 80. In the ratio 2 and 3, there is a gap of 1. But we need a gap of 80. All right, we need a gap of how much? 80. So 2 into 80 and 3 into 80. So 3 into 80 is, for example, how much? 120. Okay, 80, that is 240. So T, or this is 160. So the time T will be, comes out to be how much? 200 minutes. So you can say 200 plus 40, 200 minus 40. So we know that speed is equal to 12 and time is 200. So distance is equal to, speed is 12 and the time is 200 by 60. So 12 5s are 60 and 200 by 5 is equal to 40. Or I've already told you the equations, derive the formula. Direct formula, distance is equal to s into s plus 3. In that case, change in time is 40 and change in speed is 3, is equal to s into s minus 2. Okay, change in time here is also 40 and change in speed is how much? That is 2. 40, 40 get cancelled, s will get cancelled, and then I'll get twice of s plus 3, which is equal to s minus 2 by 3, which is the same thing if you observe here. But yeah, that's a special case. So you should know the general. If there is some special case like this one, then we can use it directly, or even if you use this, then also it is not going to take too much of time. So I hope that this is clear, that whenever there is a change in speed or change in time, then how to tackle such type of the question. Any doubts now? Rishikesh, Vishal, and everyone. And such type of the questions are very, very common. Especially, it's a very standard question. So it's not about solving the question, but how quickly we can solve. Because if I try to frame the equations, I told you also how to frame the equations in a easier way also. But framing the equation and then solving it again, 2 variable 2 equation, it might be a time consuming. But yes, so the learning from today's session is this particular concept here. So I can use it directly. All right, guys. So that's all for today. I hope that you all learned something. Okay. So in the next session, then I'll start with the concept of ratio and proportion in TST, how to apply the proportionality here. And remember, some of you might think that, okay, this ratio which I told you that it is in the ratio 3:2, it is not because of the proportionality concept. No, it is just because of the equations which we have framed. Okay, so I could have told you all this shortcut directly, but just knowing the shortcut that is not going to help. You should also know how this shortcut has been derived. That is very, very important. Okay, because if you learn that thing, then you know that in what type of the questions my shortcut will work. All right, guys. So good night to all of you. See you all today. If you like the session, please like the session and share it with your other friends also. I hope that you all are a part of Telegram group as well as the LinkedIn group. If you're not, then you can see the link of Telegram in the description. All right, guys. Okay. So good night. See you all tomorrow with something more interesting. And I'll discuss everything from basics to advanced. Okay. Starting from very basics and gradually I'll keep increasing the difficulty level. All right. So once again, good night.